Okay, if you are following us, this is our Unit 11, Day 4, 11.4 volumes of spheres and composite figures. I think the book just calls it spheres, but it definitely incorporates our composite figures in this chapter, which means mixing a couple of these shapes together. We're still talking about volume, which means filling up a shape. The volume of a sphere is 4/3 the product of pi and the cube of the radius of the sphere. So radius, remember, goes from the center to an edge. So, oops, did not mean to make that pink. This is our sphere formula. One thing you'll notice in this is pi r cubed. We haven't had an r cubed on any of them before, so that's definitely a thing to watch for. This beginning example 1 is just reviewing the volumes that we've done so far. It'll be our third day. If I just wanted to do this volume of the sphere we have at the top here, let's say it has a radius of 4. Let's see if we could find this. If you have 4/3 pi times 4 to the third power. If you ever have a problem that you says leave in terms of pi, or sometimes even on these examples in the lesson quizzes and things like that, you may see the reteach lessons have it leave it in terms of pi. So I would just do exponents 4 to the third power first and get 64. And then I would be taking 64 times 4/3. And you might get something like 85 1/3. But I often see them write like 85 1/3 as an improper fraction. Now, I don't want to waste your time, but if you ever see something like that, or they might write it as 256/3, that's just the improper version of that. That is the same as hitting 4/3 pi r 4 to the third, and this not timesing by the pi. If you divide by pi, you can still get to that. I'm going to go ahead and times it by the pi, because on all our examples, we usually just round to the nearest tenth. So 268.1 if you ever have something like that. But I just want you to see in terms of pi versus our rounded or estimated answer. This is called the exact answer. And the other one is estimated, which is the way we've been leaving most things. But I have seen a few examples where they'll leave in terms of pi and then times by the pi. So just so you know how to do it. So over this chapter, we've learned how to do volumes of cylinders and prisms. Then we did cones and pyramids. And then today we're going to talk about spheres. Volume is capital B, base area times height. This was from our day 2 with cylinders and prisms. In this case, the base is considered to be a circle, so we would do pi r squared, and then times the height, in this case is also 10. If you have 10 to the squared times 10, that is the same as 10 to the third power, or 1,000 pi. Again, that's just so if you ever see it in terms of pi, you can write that, or you can just type it in as you see it, pi times 10 squared times 10. And the volume is 3,141.6. We would round it to. And meters cubed. Reminder, when we're doing volume, we have inches cubed, meters cubed, however. This one, though, if you remember from the cone and pyramid days, when it goes to a point like that, we're going to take 1/3 the base area times the height. Our base is still a circle for this, so I'm still going to do the pi r squared. And then times the height. The only difference between example A and example B is we are taking 1/3 of our answer because it goes to the point. So you do them individually and leave pi at the end, or we can just type the whole thing in. So 1/3 times pi times 10 squared times 10. you get 1,047, about 0.2 meters cubed. So we did cylinders and cones. We've got, cylinders and prisms, and then we did cones and pyramids. And now today we're gonna do a sphere. At the top, we just learned about the sphere formula, but in this picture, this is called a hemisphere. So it's actually gonna be half of our sphere formula. So we have 4/3 pi r cubed. But then I'm gonna take half of that, so you can either times it by half or take your answer and divide it by 2. So our radius for this one is 10. So we can type it all in. You can do it in parts. You can put the fractions together by multiplying them. When you multiply all these numbers together, it does not matter which one you start with. It should come out to about 2,094.4 meters cubed. So that is an example of a sphere and a hemisphere and all the shapes that we've done volume on this chapter. So now we're going to talk specifically, what if I combine some of these shapes? So you have to recognize what shapes do we see. We have in this one, this is example 4. If you want to open up your book examples, your e-textbook, and go through step by step with that. We have a solid is composed of a right cylinder, that just means it's straight up and down, and a hemisphere as shown. If the density of the solid is 100 kilograms per meters cubed, what is the mass of the solid? So when we talk about density, we want to know the volume of it first. So we need the volume of the cylinder. Plus, we need the volume of the hemisphere. So I'm writing out the words just so you can understand what all my work I'm writing down here is. The cylinder is the pi r squared h. So for this particular one, you have to realize 2 is called the diameter, so this one has a radius of 1. Put that up. So we have pi times 1 squared times it has a height of 3. On the top, the hemisphere, we know from the middle over is 1, but a radius in a hemisphere is the same no matter if that radius goes to the side or it goes to the top. That radius is still going to be 1 no matter which direction I go. So over here on the volume of the hemisphere, we have 4/3 pi r cubed, and then times the height. The height would also be 1 because from the middle to the edge, it's still going to be 1. So that is our height, and then I need to take half of all that because it's only half the sphere. Hang on 1 second. I just had a brain break. Let's go ahead and find the volume of the cylinder then. We'll go back to that in just a second. I got to thinking, I don't think I half that. Yes, I do. Okay. Making sure my equation makes sense with their equation. My pi r squared h ends up being, see, all these are in meters, so this is 3 times pi is about 9.4, 9.42. And then if I do this other one, 4/3 times pi times a bunch of ones basically, and then divide that answer by 2 or take times 0.5, I get 2.09 or about 2.1. And then together I have a total volume of about 11.5 or 11.51, depending where you round it to. So this is in meters cubed. We found the volume. If I go back up to the directions here, it says the density is 100 kilograms per meters cubed. So I'm going to take my answer and times it by, pick another color here. So 11.1 times 100. So if you round it to 0.5, it would be 1,150, because I left it 5-1, it's 1,151. And that would be kilograms. All right, so you find the volume and then you multiply by however many grams or kilograms per meters cubed.